All right, here's a typical exam question. A curve passes through the point 0, 2 and is such that dy by dx is 2 minus x. The normal to the curve at P meets the curve again at Q. Find the coordinates of Q. First thing is we need to find the equation of the curve. So if this is dy by dx, we can write down that y is equal to the integral of dy by dx. So y is the integral of 2 minus x dx. So when we integrate 2 minus x, what we're going to get is 2x minus x squared over 2 minus x squared over 2 plus some constant of integration plus c. Now what else do we know? Now it tells us that the curve passes through the point 0, 2. So when x is 0, y is 2. So we can put that in and tell them that at P, we know that x is 0, then we get y is 2. So what's going to happen is we're going to get 2 is equal to, plug in x as 0, we get 0 minus 0 plus c, which implies that c equal 2. That's what we get, c equal 2. So since we get c equal 2 now, all right, so since we get c equal 2 now, then now we can actually write down the real equation of the curve. The real equation of the curve is y is equal to, this is minus x squared over 2 plus 2x plus 2. Nice. And then what did they tell us? They said the normal to the curve at P meets the curve at Q. So first thing is we have the curve, right? We already have the curve. We're good. We'll find the curve. But then we need to talk about the normal at P. Now to talk about the normal at P, first thing we need is a gradient at P. So at P, so we can write it right here. The gradient of the tangent at P is equal to, the x value is 0. So it's going to be 2 minus 0, which is equal to 2. So that's the gradient of the tangent at P. And so that means that the gradient of the normal at P is equal to negative a half. That's the gradient of the normal at P, negative a half. Let's put this in square box. That's the gradient of the normal. So now we can write the equation of the normal now. The equation of the normal. To find the equation of the normal now, find the equation of the normal. To find the equation of the normal, it's now going to be y minus the y value of 2, and that's equal to gradient of the tangent, which gradient of the normal, sorry, which is minus half, times in bracket x minus 0. So we'll bring this over. That means the equation of the normal is y is equal to negative a half x. Y is equal to negative a half x. Bring over the minus 2 to get plus 2. Now guess what they said? They told us that the curve meets the normal at Q. So what we're going to do is solve these simultaneously to find the point of intersection, and the point of intersection is Q. So let's solve these simultaneously to find Q. All right, so let's do this on the whiteboard. So doing it on the whiteboard, what we have is minus x squared over 2 minus x squared over 2 plus 2x plus 2. This is the curve minus x squared over 2 plus 2x plus 2. We're solving it equal to the tangent, and the tangent is minus a half x minus a half x plus 2. So solving these simultaneously, we can clearly see that this 2 cancels this 2. So bring over the minus half x over here. And so what we're getting is minus x squared over 2. Bring over this minus half x over here. So 2 plus a half is 5 over 2x, and that's equal to 0. Now I'm going to multiply through by negative 2. Multiply through by negative 2 would get x squared minus 5x equals 0. And so if you're to factorize this, you're going to get x times in bracket x minus 5 equals 0. So what you're going to get is x equals 0 or x equals 5. Now we know that at x equals 0, the y value is going to be y equal, plug 0 in this equation for y. Remember, this was the normal again. Y is equal to minus a half x plus 2 minus a half x plus 2. So if you were to plug in 0 in this equation up here, you're to plug 0 in this equation, you're going to get y equal 2 right here. And so you're getting a 0.02, but this is not p. This is not q, sorry. This is p. This is p. So it's like you have a curve and you have the normal. You have the normal at some point. So let's say this tangent, the normal, this is the normal. The normal at this point, the normal at P is going to cut the curve at another point Q. You want to find that other point Q. So all I have to do is plug in when x is 5 right here, find that y value, and that will be Q. Plug in x as 5 right here. So minus 5 over 2 plus 2, we get minus a half. So y equal minus a half. So we can definitely write that Q is the point 5 minus a half. 5 minus a half. That is definitely the point Q. 5 minus a half. Nice and easy and soft. Q is the point 5 minus a half. So we can write it down that once we solve them simultaneously, Q is the point 5 minus a half. Easy, soft.